Good afternoon, ladies and gentlemen. Let's see how digital twins can be used for project management and construction management. In fact, when I joined State Engineering Corporation in 1988 as a site engineer and subsequently started working in the design office as a design engineer, of course, we were using manual drafting to develop all the shop drawings and design drawings. And of course, I was a bit frustrated at that time because a draftsman will take 3 to 4 days to develop A0 drawing, which I was discussing with the chief engineer, Mr. Ferdinando, that there should be a better way of doing things. In fact, he explained to me that there is NBRO, a training program to train engineers on AutoCAD. I went to that training also, but they were teaching only a drawing mechanical part that was not fulfilling what I was looking for. So 1988, I left State Engineering Corporation and joined Saudi Binladin Group, where I got the training as an AutoCAD engineer to develop drawings, because you have to do the calculation, you have to develop the drawing. There is no additional draftsman except for developing the details. Anyway, this is my the starting point of using AutoCAD. Of course, that AutoCAD also can be used to develop 3D models, but it was not that versatile until we discovered this Rivet BIM technology Rivet as a tool to develop the digital model. Anyway, since 2007, I have been using this digital model in design development as well as for project management. Now, digital twin is a virtual representation of physical object, a person or a system. Here, the person is important because when you include a person in the digital twin, only you will get the proportions right. You can verify these things. And digital twins have a two-stage life cycle in architectural, engineering, and construction industry. For managing projects, effectively communicating requirements using visualization facilities of this BIM technology is the most important thing for using digital twin for project management. Because if you look at this clause 4.2.2 of PMBOK 7, it says project success is dependent on effective communication. So this PMBOK 7 is PMBOK 7 Part 1 gives the American standards for project management. Even there are other standards for project management like Prince 2 for British standards and PM2 for European standard. Whatever the standard there, it is it is known fact project success is dependent on effective communication. Now visualization facilities of this BIM technology gives a good leverage for you to use this digital twin for project management as well. And after completing up to LOD 400, you continue incorporating all the as-built details of the actual physical object. And during that time, it will be upgraded to LOD 500 by incorporating all the information that is required for operation and maintenance of the facility as well. That is the second life cycle of this particular digital twin, which I'm not an expert on that. Of course, so what we do is that once we hand over the project, this employer will hand over this digital twin to a facilities management company, those who will install all the sensors to get data and proceed with that part of the life cycle. Now you can see the video that we created from Maldives International Airport digital twin, and here is the access road, and it is leading to the departure hall, and you are entering the departure hall now. And here you get the reception desk first, and then you see the self-checking kiosks and the flight display board, flight information display board, and after that you get the counters where you can drop your baggages and show your tickets, get your sort of boarding card, and move forward to go through the immigration formalities. Now look here. Now this is the advantage of digital twin, where you create a video and you can explain everything to your employer or employer's stakeholders or the project team, so that visualization power can be used for project management. Now this is very important. If you want to develop a proper digital twin, you should follow the level of development specification. Now here what you see is that this level of detail is important, because LOD 100 you show only the elements that are as symbols, not necessarily be geometric representations. And then LOD 200 you develop this particular level, giving the elements as graphical placeholders. I mean, of course, you know this is the wall, this is the opening, this is the floor, but you don't get the dimensions and orientation and things like that. But when you go to the next level, you develop the 3D model to give the dimensions, sizes, thickness, and the orientation. And of course, this is the level by which that you can take reliable information. And if you are involved in design, a project which is designed by an employer-appointed consultant, of course, they will develop this up to LOD 300. Beyond LOD 300, LOD 350 will give the details of fabrication, or the framing, not the fabrication, the framing, because without framing, you cannot make this wall. And without considering the lateral stability and all these things, this wall will not stand. All the details can be given at LOD 350, that is framing detail. Then you go to the LOD 400, where you model elements are developed to the level of shop drawings, because you got to show the connections, you got to show the anchors, fixing arrangements, adjacent stability, stability with adjacent elements, and all these things will be shown in a LOD 400 level. Then you go to the LOD 500 level towards the end of the project, where you update all the as-built details in the digital twin and incorporate all the information that is required for operation and maintenance of the facility. That you can know which manufacturer manufactured this equipment, what is the warranty period, what is the spare part list that they have to store all the spare parts. All this information can be extracted from LOD 500, because they are there as attributes to the Revit families. Now, there is an important thing here. This digital twin technology is more effective if you are using that for a EPC turnkey contract. There, engineering, procurement, and construction will be done by the contractor. In that case, the contractor will develop from LOD 100 to LOD 500 by themselves. Otherwise, there is, of course, this is more suitable for EPC turnkey contracts. In EPC turnkey contracts, the contractor should give two types of performance guarantees. That is, one is 10% of the contract sum. The other one is that the company directors must give the personal guarantee to ensure the performance of the project. Now, in such situation, you are taking the 100% risk of the project. So a contractor should have his own control from LOD 100 to LOD 500. The other way around, the other way that you can use is for RIBA stage contracts. I will explain to you little later. Then, of course, this Dubai Sports Complex, the 3D model, you can see outside view as well as the inside view. And now you can see the physical physical object that after construction. There was a small change here in the cladding to provide some mirror finish stainless steel cladding. Other than that, everything was same as what you saw. Now you can see here the inside image of that facility, and you can see it is somewhat close to the 3D image of the digital twin. Now here you see the digital twin provided visual and interactive representation of the project, and of course the shape of the cladding and the shape of the building, everything was taken from the digital twin, because it was the best way we can explain the requirements to our project team as well as employers, representatives, the employer stakeholders. Now, of course, this is what we have done in Dubai Sports Complex. This was developed for the FINA World Championship held on 2010, December 10. And these are the structural installations that we again follow the digital twin to get all the details, explain everything using the digital twin. And of course, finally, we delivered the project on time. And then here the Dubai Safari digital twin and physical asset. And you can see the digital twin of Dubai Safari here. And of course, this is what we finally constructed as physical asset. And of course, this was an RIBA stage contract where LOD consultant appointed by the employer developed the model up to LOD 300, and then we took over and continue LOD 400, 500 level. But here, once we started developing the design further, we changed the concrete framing structure into the steel structure, and you can see that installation going on in the steel framing, and you can see the digital twin is somewhat similar to our image as well. And here I'm inspecting the fabrication of this box sections as framing. We use 8mm thick steel plates to fabricate the box section with welding. So in fact, consultant was not happy, and they were telling the Binladin is making money by changing the design and all these things. But my boss was very adamant, and he said, Nihal, you better inspect all these things and make sure everything is done right to have no issues. Now you can see this image where we explain the labor using the digital twin, what they are going to execute daily basis in particular toolbox meetings. This is also important that you use the digital twin to explain things to people, because they can easily understand the scope of work. Now this is what Maldives Airport digital twin. You can see the building from the air side, as well as you can see most of the aircraft parking locations also marked on the ground. This yellow line is the location where the pilot will move his aircraft until he bring these tires to that stop point and keep 2 blocks on either side of this tires. And this location is decided based on the passenger boarding bridge reach, because passenger boarding bridge is a telescopic tunnel, and the slope, because if the slope is more than 10%, people cannot walk. And because based on that concept, we decide the parking location first for each and every type of aircraft. You know, in any contact pier, there can be so many aircrafts coming and getting these passengers reaching the terminal through this contact pier. Now, importance is that once you know the parking location, you know the fuel storage is on the wings of the aircraft. So fuel hydrants must be located in such a way the fuel dispenser can supply fuel, into the tanks of these particular wings of the aircraft. Now, there again, is not only one aircraft. Now I am showing you A380 Airbus here, but there can be other aircrafts also. Depending on all types of aircrafts, you see whether the reach of the dispenser is sufficient to supply this fuel. And similarly, these aircrafts operate on 440 volt power supplies. Now, it doesn't work to 30 power supply. Now, you must provide a ground power unit, which is basically a step-up transformer to provide the 440 power. Now, this ground power unit location is also based on the location of this power supply point of parked aircraft. Not only that, you can see these yellow lines, and there is a advanced visual docking guiding system by which that the airport, pilot is guided by that particular system, AVDGS, Advanced Visual Docking Guiding System. What happens here is that it has the capability of identifying what the aircraft coming in. They use laser technology or the imaging technology to identify the aircraft, and he can get the distance that the pilot should move his aircraft along this line to reach that particular parking point. Of course, if the aircraft is deviating from the line that is marked, this AVDGS can give the directions where to move the aircraft in such a way that it comes on the straight line. Now, this type of coordination can be easily done based on this digital twin. Not only that, now when an aircraft is parked, there are ramp services to be provided by the airport authority. Now, for that, you need movable stairs, loading and unloading cargo platforms, and belt type loading belts, and of course waste water removal and water supply tanks. Everything has to be moved around this aircraft, and these locations can be marked on the ground, again using digital twin. So this is what we have used in this particular 3D model to do this interfacing and coordination to make sure that all the operations are carried out smoothly, and this particular sort of arrangement, stopping arrangement, is quite conversant with the operations that are required at the ramp level. Now here, there can be different types of aircrafts. I told you A380 can bring about 550 passengers, and of course to at least loading or unloading you need at least 3 tunnels, telescopic tunnels or passenger boarding bridges to ensure that that loading and unloading is taken over by this particular staff within the required time allowed for them to complete the task. Now, efficiency, of course, the other types of aircrafts like SSJ 175 and Boeing 777, you can see all these things. Now you see the elevation of this digital twin from the land side. Now there is a story behind this. This land side, you can see the curtain wall inner, and then you have a corridor where the people can move into this arrival and departure areas. And we issued this 3D model, and we derived all the shop drawings for piling work and the foundation work. We started piling work and foundation work, and I got a call from His Excellency the President of Maldives, and we had a meeting, and he was telling me, Nihal, you have done an excellent job, but you have not reflected the Maldivian values in this particular airport development. He was telling you outsource this design part to European company, so they have incorporated all these European values in this particular design. So I asked His Excellency what exactly he want. Then he said, Maldives, you have all the sea around and white sandy beaches. If I can reflect this wave design and white sandy beaches, that would be ideal. So I spoke to my architect, and this is what she developed as a facade reflecting these waves and white sandy beaches. It was not a big change, but of course this airport terminal building 500-meter long. So when you do this change, we added this ceiling here and this facade, vertical facade here, and original curtain wall, we didn't do any change. Now when it takes to the 500 meters, of course, it will cost them about 40 million US dollars. And of course, that time, head of the state is giving instruction to the contractor in front of the employer's appointed consultant. He was not happy because when I said, we will fulfill your requirement, Your Excellency. And of course, that time it was COVID. So it was to my advantage to get a variation completed, because during that time I can do all the design work from my office. Now here you can see the digital twin on left side, and on the right hand side the actual property is being constructed. Now even the facade, you can see the digital twin on left hand side. On the right hand side, actual execution you can see. All this digital twin, we use the Revit, Autodesk Revit to develop this 3D model. Now you can see a video that he created from the corridor where the passengers coming down from the flight and reaching to the immigration department. And you can see every detail is reflected in this 3D model, and it is easy to convince others about these requirements and the details. By creating such visual reflections of the project, it allows the project manager to have unprecedented control and insight into every aspect of the project. Now, this is very obvious here. And now you are entering into the immigration office, where you can see these black desks and cabinets for immigration checking. Here you hand over your passport and they will verify your visa status. If it is acceptable, they will allow you to enter to the country. And once you enter past this immigration desks, you go to a scanner where it will scan your hand luggage. Now there you need certain furniture there as well, and all that is reflected in this 3D model. And of course, then you go to the baggage handling area after passing the scanning log process. Now you can see that digital twin provide a common platform for stakeholders to share information, coordinate tasks, and make decisions. This is the advantage of digital twin to use for project management. Now you can see here a rendering of the toilet, mirror side as well as back side. Now that gives all the details of this particular toilet in one shot. And of course we can get the approval based on this image, and you can see a man model contains a man as well, a person as well, so that will reflect the proportions of this particular design. So this is the advantage that we take because it is easy for us to convince the employers, stakeholders about the design and approvals on that as well. And then the next advantage that we took from the digital twin, you can exchange information which is vital for the project success, because we developed the BIM model separately, structural model separately, architectural model separately, MAP model separately, and we get digital twins of the suppliers. Now, for example, this is the passenger boarding bridge digital twin. So we incorporate that in our 3D model. Now, when you integrate all these separate models developed separately based on disciplines, you will find clashes. Now, Naviswork is another tool by which you can automatically detect clashes, and it will give a snapshot of the clash, and it will give the description of the clash. Then you can sit down with your structural engineer, architect, and the mechanical and electrical engineers to resolve all these conflicts, because you only define what is conflict, what is the overlap, and all these things. This Naviswork will automatically give you the report. Now, based on that report, you can collaborate very well with your project team and design team, and make all these corrections before construction starts. If you start construction and find clashes, it will be a disaster, because it will cost you a lot of money. Now, this interface detection and management system allows us to anticipate and prevent and develop the construction without breaking the construction activities and losing money. Now, for that to happen, to get this project management part done, you got to break this scope of the work into small packages, and these packages should be known to your this BIM technician. Based on that, he will follow the construction sequence in developing his 3D model. Now, 13 passenger boarding bridges, 6 contact piers, passenger terminal building, West PTB road, and seaplane checking, parking slots, and central utilities complex, by which that you provide all the energy requirements to operate the passenger terminal building. All that are major parts of the scope breakdown of this particular design. Of course, existing terminal building also there, but there are certain enabling work, like this existing terminal building going to be the future domestic airport. So domestic terminal must be connected to the new terminal to get the baggage from this domestic terminal to international terminal. So such work, such modifications in existing airline building modification, other building shifting and demolition. Pier bridge also is encroaching into the new terminal building area. So all these things, the enabling work and the new work also break into different parts. Now you can see 13 kV underground power line also modeled in the digital twin, because this it is one of our scope of work, because while developing the new terminal building, we must make sure the existing terminal building operates. To existing building to operate, this 13 kV underground power line should not be disturbed. So it is there in the model itself. Of course, when we fix the tower cranes, it started going over the existing airport road where the public transportation is happening. So we had to put a diverted existing airport road to make sure that that is also in the scope of work. Not only that, the planning engineers have a thumb rule. They should break all the scope of work into the small packages and activities which can be completed minimum 4 hours or maximum 40 hours. Now, when you do such breakdown, such decomposition, you have to break the building also into zones. Zone 1, Zone 2, Zone 3, Zone 4, and level 1, level 2, level 3, and underground. Like that, we develop the work breakdown structure, which is shown in this. Now, the level 1 is your project, and level 2 work breakdown structure is the phase 1 and phase 2. Phase 1 give the enabling work, phase 2 give the new work. And of course, even the phase 1 and phase 2 further decompose based on the disciplines, because you saw that all that work is reported as a progress based on the zones. Now you can see the foundations are constructed based on the zones, and then you construct the concrete slabs, again based on the zones. Now you can see these 3 tower cranes that I told you that was going over the public transport road. And finally, we installed the MEP work and the structural steel work. And you can see the date is running. Every progress update is based on each date. So this is how we use this digital twin for project management purposes. And then here in the Revit, you have dialog box by which that you can give all the information of systems, equipments, everything in digital form, so that they are embedded into the digital twin as attributes. Now, this is the biggest advantage that we have. And here you can see this bird's eye view of this model. And I hope you understand the importance of using digital twin in developing your design as well as managing the project. Thank you so much.